Refresher course on window, fixed speed, and inverter mini split AC. Presented by Scholenberg International Private Limited. Leaders in trainings and content development worldwide. Disclaimer. The information contained herein has been obtained from very reliable sources, experiences of the author and extracts from the Internet. The author disclaims all warranties to the accuracy, completeness, or adequacy of such information. The author shall have no liability for errors, omissions, inadequacies in the information contained herein and interpretations thereof. The author, and all those who assisted in preparing this tutorial, shall not be responsible for loss of any kind, whatsoever, sustained by any person who relies on this material. Every effort has been made to trace the owners of the copyright material included in this presentation. The author would be grateful for any omissions brought to his notice for acknowledgements in future editions. The material and communication methodology in this presentation is copyrighted. No parts of this presentation may be reproduced, stored, or distributed in any form or by any means either on paper or electronic media, unless authorized by the author. The author, Arvind Dhawan, is a mechanical engineer with specialization in air conditioning with over 45 years experience in air conditioning and utility domain. He is an ex-Blue Star consultant trainer, subject matter expert and certified lead trainer, level 6 with Electronics Sector Skills Council of India, ESSCI, under the Ministry of Skill Development and Entrepreneurship Government of India, and a visiting faculty with ISHRI. He has contributed to the following: 1. Handbook for Technicians, Air Conditioning and Refrigeration by ISHRI. 2. Multi-Skill Technician Handbook by CARE, Voltas. 3. Trainers PPT, FTAC for ESSCI. 4. App Contents FTAC for ESSCI. 5. Revamping refurbishments of the course materials for ISHRI. Now, he is developing animated multimedia contents on the entire air conditioning canvas and home appliances. These are available online from Scholenberg International Private Limited. https://sbgblv.com. Index. Serial. Topic 1. Fundamentals of air conditioning. 2. Window AC. 3. Fixed speed mini split AC. 4. Inverter mini split AC. 5. Working of components. 6. Best practices. Fundamentals of air conditioning. What is an air conditioner? An air conditioner is like a goods transporter that shifts goods from one place to another place. Take the example of a mini split air conditioner. It shifts the heat from inside a room by the IDU, indoor unit, to outside the room by the ODU, outdoor unit. Pressure. It is the force applied upon unit area. It can be pound per square foot or kg per square centimeter. Atmospheric pressure. It is the pressure of the atmospheric air of Earth, also known as barometric pressure. This is equivalent to 760 mm Hg, Hg equals mercury. 29.9212 inches Hg. 14.696 psi, pounds per square inch. Measurement of pressure. Pressure above atmospheric pressure is measured by a pressure gauge. 0 on this gauge is 1 atmospheric pressure. Below the atmospheric pressure is vacuum. It is measured by a compound gauge or a micron gauge. Temperature. It is the degree of hotness or coldness of a body. It does not indicate the quantity of heat. It is measured by an ordinary thermometer. Units of temperature. The most commonly used units are degree centigrade or Celsius. In this scale there are 100 divisions 0 to 100. Degree Fahrenheit. In this scale there are 180 divisions 32 to 212. What is a vacuum space? It is a space in which there is no matter, or in which the pressure is so low, that any particles in this space do not affect any processes being carried on here. In an air conditioner, before refrigerant filling, there is air in the system. The air conditioner works on the principle of compression of refrigerants. So, if any air is present, it has to be removed. This is done by creating a vacuum, using a vacuum pump. The gauge used to measure is an electronic instrument called the micron gauge. The unit for measurement of vacuum is micron. Pressure, temperature chart of R22 refrigerant 2 to 24 degrees centigrade. Pressure, temperature chart of R22 refrigerant 34 to 56 degrees centigrade. Pressure, temperature chart of R32 refrigerant 2 to 24 degrees centigrade. Pressure, temperature chart of R32 refrigerant 34 to 56 degrees centigrade. Pressure, temperature chart of R134A, refrigerant 2 to 24 degrees centigrade. Pressure, temperature chart of R134A, refrigerant 34 to 56 degrees centigrade. Pressure, temperature chart of R410A refrigerant 2 to 24 degrees centigrade. Pressure, temperature chart of R410A refrigerant 34 to 56 degrees centigrade. Operating head pressure. The operating head pressure, or also called discharge pressure, of a window or split AC depends upon the ambient temperature. The temperature difference between ambient air temperature and the condenser discharge air temperature is assumed as 10 degrees centigrade. Assume that the ambient as 40 degrees centigrade. So, the discharge air from the condenser shall be 40 degrees centigrade plus 10 degrees centigrade equals 50 degrees centigrade. For discharge pressure, refer to the pressure minus temperature chart of the refrigerant that is used in the system. The results are given below. Operating suction pressure. The operating suction pressure depends upon the room temperature. The temperature difference between supply air and return room air should be at least 10 degrees centigrade. Assume that the room temperature is 24 degrees centigrade. Supply air will be 24 degrees centigrade minus 10 degrees centigrade equals 14 degrees centigrade. Temperature of the refrigerant in the cooling coil will be supply air temperature minus 5 degrees centigrade equals 14 degrees centigrade minus 5 degrees centigrade equals 9 degrees centigrade. Assume superheat as 3 degrees centigrade. Temperature of suction gas equals 9 degrees centigrade minus 3 degrees centigrade equals 6 degrees centigrade. For suction pressure, refer to the pressure, temperature chart of the refrigerant that is used in the system. The results are given below. Heat. Heat is kinetic energy that flows from one object to another. It always flows from a hot object to a cold object. Enthalpy. It is the total heat content in a body. The unit is BTU per pound. Cooling capacity. Cooling capacity is the measurement of a cooling system, and its ability to remove heat from a space. The cooling capacity of air conditioners is expressed as ton or TR. TR equals ton of refrigeration. 1 ton equals 12,000 BTU per hour. Equals 3024 kilocalories per hour. Equals 3.5 kilowatts per hour. BTU means British thermal unit. kcal means kilocalorie. kW means kilowatt. States of matter. All matter on this planet is in 3 states. 1. Solid. 2. Liquid. 3. Gas. The states of all matter can be changed by adding or subtracting heat. Examples. Subtract heat from liquid water. It changes to solid ice. Water minus heat equals ice. Add heat to solid ice. It changes to liquid water. Ice plus heat equals water. Types of heat. There are 2 types of heat. Sensible heat. This is heat which you can sense, meaning you can feel this heat. When this heat is added or removed, there is change in temperature but no change in the state. This can be measured by an ordinary thermometer. Latent heat. This is the heat required to bring about a change in state of a body. This heat you cannot feel, nor can you measure it by an ordinary thermometer. When this heat is added or removed, there is no change in temperature. Heat transfer. Conduction. This happens when 2 bodies come into physical contact with each other. Let us take 2 blocks. One is hot and the other is cold. Now, the 2 blocks are brought into contact with each other. Heat transfer starts taking place, from the hot body to the cold body. Finally, heat in both bodies reach an equilibrium temperature, which is the average of the 2 initial temperatures. Then heat transfer stops. This type of heat transfer is called conduction. Convection. When heat transfer takes place from one place to another in fluids and gases is called convection. There are 2 types of convective heat transfer. 1. Free or natural convection. In this the fluid motion is caused by the density variation or temperature variations. 2. Forced convection. There are 2 types of forced convection. A. Induced type. In this the fluid is sucked over the heat source. B. Forced type. In this the fluid is forced over the heat source. Radiation. Notice the flame below. Heat travels upwards by convection. But it also travels sideways by electromagnetic waves. Electromagnetic radiation can be described as a stream of massless particles, called photons, each traveling in a wave-like pattern at the speed of light. Animation of heat transfer in a condenser. This is an example of conduction and convection. The thermometers indicate temperatures of the air before and after the condenser. Conduction, in the metal parts. Convection, in the air. Application of condensers. 1. Induced draft. This type is used in split air conditioners. 2. Forced draft. This type is used in window air conditioners. Basic vapor compression refrigerant cycle. Refrigerant. A refrigerant is a substance used in air conditioners, to transfer heat from one area to another. R22 is monochlorodifluoromethane. It has a chlorine content that damages the ozone in the atmosphere. Because of this and the global warming taking place, alternative refrigerants are being used. Factors to be considered in selecting refrigerants are ODP and GDP. ODP, Ozone depletion potential. It is the measure of ozone depletion potential of a refrigerant, as compared to CFC11. ODP index of CFC11 equals 1.0. GWP, global warming potential. It is the index that compares the warming effect of different refrigerants by unit weight as compared to carbon dioxide. GWP index of carbon dioxide equals 1. Commonly used refrigerants for air conditioning. Comparative rating, 1 to 7, where 1 is the best, and lowest overall points is the best. Window AC. Window AC is one that is installed inside a window. Below is the animation of the installation of a window AC. Basic parts of a window AC. 1. Chassis. 2. Front panel. 3. Outer cabinet. Images of parts of a window air conditioner. Parts installed on the front panel. Serial. Name of part. Image. 1. Front grille. 2. Air filter. 3. Horizontal louver. Parts installed on the chassis. 1. Vertical louver. 2. Vertical louver link. 3. Exhaust. 4. Swing motor. 5. Main PCB and display PCB. 6. Dual capacitor. 7. Air sensor. 8. Coil sensor. 9. Blower motor. 10. Compressor. 11. Condenser. 12. Cooling coil. 13. Capillary and filter assembly. 14. Blower scroll. 15. Condenser fan blade. 16. Ribbon cable. 17. Main cable. Fixed speed mini split AC. Images of parts of a fixed speed mini split air conditioner. Parts installed on the IDU. Serial. Name of part. Image. 1. Front panel. 2. Cooling coil and IDU body. 3. Main PCB and display PCB. 4. Air sensor. 5. Coil sensor. 6. Horizontal and vertical louvers. 7. Swing motor. 8. Blower wheel. 9. Blower motor. 10. Condensate shield, above blower wheel. 11. Condensate tray. Below blower wheel. 12. Mounting plate. 13. Drain pipe. 14. IDU union connectors. 15. Air filter. Parts installed on the ODU. Serial. Name of part. Image. 1. Compressor. 2. Condenser. 3. Condenser fan motor. 4. Condenser fan blade. 5. Compressor capacitor and fan capacitor. 6. Service valves. Inverter mini split air conditioner. Working of an inverter AC. 1. Inverter AC is like any other fixed speed AC. 2. The difference is that in inverter AC the compressor speed is changed according to the cooling needs. 3. Compressor speed is changed by an electronic circuit. 4. In this electronic circuit, 230 volt 50 Hz frequency AC is converted into DC. 5. Now this DC is reconverted into three-phase AC, PWM, with variable voltage and variable frequency. 6. Output frequency varies from 0 Hz to 120 Hz. This is controlled by IDU room temperature. 7. Variable frequency results in variable voltage which is supplied to the compressor. 8. The variable voltage changes the speed of the brushless DC, BLDC, compressor motor. 9. In this way the compressor speed changes according to the room temperature. Waveforms in a mini-inverter split air conditioner. Animation of an inverter AC. As the temperature reduces, the speed of the compressor reduces. Images of typical parts of an inverter mini split air conditioner. Serial. Name of part. Image. 1. Indoor unit PCB. 2. Outdoor unit PCB. 3. Display PCB. 4. Reactor. 5. OLP. 6. Four-way reversing valve. 7. Air sensor. 8. Cooling coil sensor. 9. Discharge sensor. 10. Condenser sensor. 11. Ambient sensor. Working of components. Working of a hermetically sealed rotary compressor. Rotary compressor, window and mini split air conditioners. The compressor is usually a rotary type. In this type there is a roller that moves eccentrically inside a compression cylinder. The motor winding is surrounded by the hot discharge refrigerant. As the roller moves, it squeezes the refrigerant out of the cylinder. A spring-loaded blade separates the high side from the low side. There is no suction valve. The discharge valve is located outside the cylinder, and it opens outwards. Therefore, the refrigerant displacement is 100% and not intermittent. Accumulator. The suction refrigerant enters directly into the compression chamber. Therefore, it is very important that the refrigerant does not contain any liquid refrigerant particles. An accumulator is used to ensure this. The animation below shows how an accumulator traps the liquid refrigerant. Working of a hermetically sealed reciprocating compressor. Below is the image of a hermetically sealed reciprocating compressor. The motor winding is surrounded by the cold suction refrigerant. In this type a piston moves up and down in a compression cylinder. When the cylinder moves up, the refrigerant is compressed. The discharge valve opens outwards. The suction valve opens inwards. A space is left above the piston for the opening of the suction valve. Hence, some of the refrigerant always remains trapped here, and does not leave the compressor. Capillary. A capillary is a copper tube with a very small inner bore. Its purpose is to reduce the pressure of the liquid refrigerant by resistance. As the refrigerant passes through the capillary, the pressure drops. The different colors in the animation indicate a decrease in refrigerant pressure along the way. Working of air and coil sensor. Air and coil sensors are thermistors. A thermistor is a type of resistor, whose resistance changes with temperature. These sensors are of NTC type. The resistance of the NTC sensor decreases as the temperature increases. So, when the temperature rises, this sensor allows current to pass through it, which activates a transistor in the IC. A DC voltage passing through the transistor operates a relay. The relay coil becomes an electromagnet which pulls the plunger of the contacts. Now this contact completes the compressor or the motor circuit and they switch on. Best practices. Vacuumizing. Vacuum must be carried out by a high vacuum pump up to 500 microns. If this not done so, some air will remain in the system. Effect of air in an air conditioner refrigeration system. The major part of air is made up of nitrogen and oxygen. Both are very high pressure gases. This will result in 1. Higher discharge pressure. 2. Higher suction pressure. 3. Reduction in cooling effect in the air-conditioned room. 4. Higher current drawn by the compressor. This animation shows the air traveling along with the refrigerant throughout the system. This is shown as a black dot. The components of air are 1. Nitrogen 78%, 2. Oxygen 21%, 3. Other gases 1%. Air also contains moisture. This travels along with the refrigerant throughout the system. This is shown as a blue dot in the animation. Moisture reacts with the refrigerant resulting in corrosive acids. This will cause 1. Damage to the metal parts. 2. Damage to the compressor motor windings. Never use a reciprocating compressor for vacuumizing. Reason: in a reciprocating compressor the displacement by the piston is never 100%. Some gas is always trapped above the piston which is never displaced. Therefore, it can never achieve a 500 microns vacuum, which is required. See the animation below. A vacuum pump is a rotary compressor. The displacement is always 100%. Use of LOTO. LOTO stands for lock, out, tag, out. It is a device used to lock the main electrical switch, so that it cannot be switched on accidentally. See the animation below. Here, the LOTO screw locks the MCB lever. In this position, the MCB cannot be switched on. LOTO use procedure. The IDU and ODU are at two different locations. If a technician is servicing the ODU, and if some other person switches on the power supply, then this will result in an accident. So, the technician should lock the LOTO and carry the key, so that no one can switch on the power. Measurement of voltages. The voltage between neutral and phase for single-phase supply should be measured by an analog multimeter. This voltage should be 230 volts plus or minus 10%. The voltage between neutral and earth should be measured by a digital multimeter. This voltage should not be less than 2 volt and more than 5 volt. Importance of neutral and earth voltage. This voltage between neutral and earth is very important, because the ODU, PCB is earthed. In the animation the earth circuit is shown by a green dot. Testing an air conditioner sensor using a digital multimeter. Air conditioner sensors are NTC type. Method 1. 1. Take a digital multimeter and set it in resistance mode. The symbol is shown here. 2. Now connect the two needle probes to the sensor leads. 3. It will show a resistance. Check this resistance from manufacturer's data. 4. This should match with the manufacturer's data. Method 2. 1. Take a digital multimeter and set it in resistance mode. 2. Take the resistance reading of the sensor. 3. Now, rub the sensor with your fingers. 4. After rubbing, again take the resistance reading of the sensor. 5. If the sensor shows a decrease in resistance, it is okay. This is because, in an NTC sensor the resistance decreases when the temperature increases. Testing of a capacitor using a digital multimeter. 1. Take a digital multimeter and turn the selector switch to capacitance mode. The symbol is shown here. 2. Connect the red banana jack to point with capacitor symbol and the black banana jack to COM. 3. Discharge the capacitor by shorting the terminals with a screwdriver. 4. Now, connect both probes to the capacitor. 5. The capacitance reading will appear on the display. 6. Check the reading with the value printed on the capacitor. The variation allowed is plus or minus 5%. Using ladders. 1. Positioning of a ladder. The rule is 1:4. If the top of the ladder is at a height of 12 feet, then the base of the ladder shall be at a distance of 3 feet from the wall. 2. Climbing posture. When climbing, 3 parts of the body must be in contact with the ladder. Selection of refrigerant cylinders. The following refrigerants are used in window, many split air conditioners and automobile air conditioners. R22, R32, R134A, R290, R410A. Now all these refrigerants have different properties. The most important of these are their pressures. The table below shows the pressures of these refrigerants at different temperatures. As an example, the pressure of R410A is almost twice that of R22. So, when selecting a cylinder, look for the embossed marking on the cylinder which mentions the refrigerant. Refrigerant recovery setup. Because of the harmful effects of refrigerants, they must be transferred into a refillable cylinder by a recovery unit. Never top up R410A. R410A is a mixture of R32 plus R125 in the ratio 50%. It will cool effectively only if this proportion is maintained. Both these refrigerants have different densities. Density at 30 degrees centigrade. R32 equals 958 kilograms per cubic centimeter. R125 equals 1248 kilograms per cubic centimeter. R32 is lighter than R125. So in case of any leakage, more of R32 will escape. Therefore the proportion of the balance R410A in the AC is disturbed. So, even after topping up, the proportion will never be in the ratio 50%. This means that the AC will never cool properly. Therefore never top up. Minor leaks normally takes place from the shredder valve. So, after repairs, the whole refrigerant must be transferred into a recovery cylinder. Then carry out the vacuum up to 500 microns, and charge fresh R410A. Pressure testing. Use nitrogen gas along with a 2-stage nitrogen pressure regulator. Leak test pressure. Leak test pressure equals maximum operating pressure multiplied by 1.25. Below is the table showing the recommended nitrogen test pressure. Pressure testing setup with Loto. Installation of window AC. 1. There should be no obstruction behind the AC. In case of any obstruction, the condenser discharge air will short cycle. This will result in high head pressure, and may cause tripping of the compressor. If there is any obstruction, it must be at least 2000 mm away. 2. The AC should slope backwards approximately 5 mm. This will prevent condensate water seepage. Installation of IDU of a split AC. The following are the recommended distances to be maintained. Installation of IDU of a split AC, continued. Use a spirit level to ensure the slope of the IDU mounting plate. Installation of ODU of a split AC. It is best that the condenser 1. Does not face direct sunlight. 2. Does not face strong winds. This will result in high head pressure, and may cause tripping of the compressor. Servicing of IDU of a split AC. For best performance, uninstall the IDU and remove the coil. This is necessary for 100% cleaning. For this, understanding of the construction of the IDU is important. Points to note. 1. The cooling coil is C-shape. 2. The blower is behind the coil. 3. A top drip plate is above the blower. This tray and back plate is in one piece. 4. A bottom drain tray is below the blower. This tray and back plate is in one piece. 5. After the coil is removed, these trays are exposed. 6. Now the trays and the drain hole can be cleaned properly. 7. After dismantling, the coil top can also be cleaned properly. Images of servicing of IDU of a split AC. Images of servicing of IDU of a split AC, continued. Evacuation and refrigerant charging in an air conditioning system. Process setup. Arrange the setup as shown below. Evacuation process. Note cylinder valve V4 will remain closed throughout the evacuation process. Step 1. Open V1 straight ball valve. Step 2. Open V2 compound gauge valve. Step 3. Open V3 discharge gauge valve. Step 4. Open SV suction service valve using an Allen key. Step 5. Start vacuum pump. Note the micron gauge readings. When the vacuum reaches 500 microns, close the discharge gauge valve V3, and stop the vacuum pump. Vacuum will begin to rise. If it does not exceed 1500 microns, it means that there is no leak. The vacuum process is complete. Step 6. Close straight ball valve V1. Refrigerant charging process. Ensure that valve V1 and V3 are closed throughout the process. Step 1. Note the weight of the refrigerant cylinder on the weighing scale, 5000 grams. Step 2. Open V4 refrigerant cylinder valve. Refrigerant will begin to enter the AC unit through valves V2 and SV. See the level of the refrigerant drop in the cylinder. Step 3. When the compound gauge reads 100 psig, start the AC unit. Step 4. Regulate the flow of the refrigerant from valve B2. Note the weight of refrigerant cylinder, 4,200 grams. The difference of the weights of the cylinder indicates the weight of refrigerant that has entered the AC unit, 800 grams. Step 5. When the desired quantity of refrigerant has entered the AC, close V4 and V2. Run the AC for about 15 minutes. Check the suction pressure, amperes, and the room conditions. If delta T equals to or greater than 10 degrees centigrade, then the refrigerant charging process is complete. Step 6. Close suction service valve SV. Step 7. Remove the setup. Performance test of a split AC. Start the split AC. Run it for about 15 minutes. Measure the room return air temperature T1 and room supply air temperature T2. The difference between these temperatures is delta T. Now, delta T should be equal to or greater than 10 degrees centigrade. Check the current drawn by the AC. The amperes for a 1.5 ton split AC is generally between 7 to 9.5. This depends upon the ambient temperature and the star rating. Comparative of window, fixed speed split and inverter split AC. References and acknowledgements. 2009 OSHRI Handbook Fundamentals, SI, Chapter 30. https://www.google.com. Arvindavan. End of the tutorial on window AC, fixed speed, and inverter split AC. Thank you for being a part of this learning process.